What I want to do today is somewhat different than what I had planned to do, and I'll explain why. There's two reasons. First, yesterday I was not able to give my workshop. It was my choice not to give the workshop because I felt it was much too important for us to be in the Eshrafolu Mosque in Beshahir, and for all of us to have an opportunity to look at the monument together. So the lecture that I thought I would be preparing for today has turned into a seminar, much more informal, and I've asked to do 15 minutes of my workshop first. It was supposed to be an hour-and-a-half workshop. I'm only doing a small part of it. And then move into my lecture, but move into my lecture in a manner that relates it directly to the Eshrafolu Mosque that we saw yesterday. So we'll start with the slide and leave it on while we do the workshop. And what I would like everyone to do is take one plate, and on the circumference of the plate, make one mark, 1 point, anywhere. So like this, 1 point. And what this does conceptually is bring us back first from very complex patterns that we were looking at yesterday. The most complex patterns, perhaps in Islamic art, certainly the most complex patterns in Islamic art up to this date of the end of the 13th century. Bring us back to 1 point. Now, that point really should be in the center, but we don't yet know where the center is. Okay, so mark 1 point. Now, mark another point, anywhere. Anywhere. It can be right next to it. It can be all the way across from it. It can be anywhere on the circumference. But it must be in the circumference. It should not be in the circle. So on the line, the collection of points that creates the circle, mark 2 points. Then take your 2 points. Everybody has it marked twice. Okay, take your 2 points, put one on top of the other, and fold the circle. Yasha. And what did you get? What did you give it a nice good crease? What did you get? Everybody hold up what they got. Everybody put their marks in the same place. Is that right? Everybody put their marks in the same place. No, right? So, okay, why, if you put your marks, look at your neighbor. Did they put their marks in the same place as you? No? Why did this happen? Why did everyone get a semicircle no matter where you put your 2 points? Why did this happen? Can someone speak up? Do we have a microphone? A microphone to pass? Why did this happen? Erica? It's because it's a circle, but okay. What if it was a triangle? It wouldn't be the same. Why is it the same? Because it's a circle. What have we done effectively? Yes.
These are separated points. They are actually connected in the center.
They are connected both to the circumference and to the center. We don't know yet where the center is. But effectively, by folding the paper plate, we have created a chord. Okay, that's supposed to be a straight line, right? A chord. We've created a chord that when you bisect the chord, it goes through the center of the plate. Okay, let me show. That chord, when you bisect it, it goes through the center of the circle, no matter where the chord is located. Okay, so through paper folding here, we have bisected, we have created a chord, we have bisected it, but we still don't know where the circle is, where the center is. Okay, so where is the center? How can you find the center as if you were constructing it with a compass? How can you find? You could take two other points and do the same, but there's an easier way to accomplish this. Yes, another way would be you have your diameter folded in half. But what else? That's all very specific. Two other points, you're creating points. Folding it in half, you're using the existing diameter. I want to bring us back to that relationship between point and center.
Can I just pick one of these folds and either them by themselves or again with this?
You can fold anywhere you want on the plate to create another semicircle. Anywhere at all. One step. Fold it in half, but then you're using the diameter you already have. Right? This way you're starting again from anywhere. Right? And the intersection of those two diameters gives you precisely the center point of the circle. Now, it's absolutely right, you could fold it in half again and establish the circle, but then you're pre-selecting only one diameter. Whereas this way, you begin to get a sense of the inherent geometry in the circle itself. So let's stop for a moment and talk about what are the properties of a circle. What are the properties of a circle? Equality, and let's call that a uniform curvature. Every point is equally distant from the center point. The curve is uniform all the way around the circle. Anything else that we want to bring out at this point? More will come out as we do the seminar. Now, I could go to a next step, but I think I'm going to stop and switch gear. And if we want to return to this workshop, could you pass these around? And everyone should, again, get 2 sheets. I better keep 2 for myself. Oh, thanks, Hussein. Here. What I want you to do is fold the square in half. And in other workshops, I might ask people to fold it in half any way they want, and they usually come up with a rectangle. But of course, you can also come up with a triangle, and there are infinite other possibilities. But let's stick with the rectangle in the interest of time. Fold it in half to create a rectangle. Knowing that you're starting with a square is given. Sorry. Let me just take this off. A square is given. What is the relationship of side A to side B? You know, all the sides of the square are equal. We folded it in half. Effectively, we've divided by 2. What is the relationship of side A to side B? Not equal. 1, 2, 2. Or 2 to 1, 1 to 1/2. Either. It gives the same proportion. Okay, then fold it in half again. Everybody got 2 sheets, right? Or did I say 1 sheet? I said 1. I meant 2. Do we have enough? We're going to use both of them. Yeah, you have 2. Some people have 2. Okay. So fold it in half again, and fold it in half again, and fold it in half again. So we've done 2 times 2 times 2 times 2. How many is that? Don't open it up. How many is that? 2 times 2 is 4, times 2 is 8, times 2 is 16. So our little gift here when we open it up, 16. Okay. Because by folding, we divided, right? And now by opening 2, 4, 8, 16, we have multiplied. So what else have we done? We've created a grid. What's the Turkish word for grid? Grid. Şebeke. Şebeke, that's a really good term. Izgara. Okay, şebeke works even better because then it relates to the patterns. But grid in English. And you can see it's a grid of squares. And what this is, I should preface this by saying what my workshop is intended to do is get to the very basics of the geometry that we're working with in Islamic art. I mean really basic, kindergarten basics. But what it also represents is my vision of how mathematics should be taught in the elementary school level and why we never learned that this is a model for all arithmetic functions. So you can add 3 plus 1, 2 plus 2, 4 plus 4. You can subtract, you can multiply, you can divide just as we have done. It gives us squares and square roots. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. What would be the next? 16, and what would be the next? 25. Taking it in the opposite direction, square roots, we can go all the way down this diagonal line from 25 to 16 to 9 to 4 to 1 and have the series of square roots in reverse order. Now, if we take this one square, how many squares surround it? 3. And how many squares surround the 3? 5. And how many squares surround the 5? 7. 1, 3, 5, 7. What would be the next? 9, 11, 13. And what we've established is the series of odd numbers. Okay, we can also go further and find other elements of number theory in this one piece of paper. Why aren't we taught this in elementary school? Okay, I want to take your second piece of paper now and do something a little bit different. And I hope I'm going to do this right. So I want you to take this corner, any corner, as a fixed point and fold a triangle. A triangle is a triangle of any angle. It works better if it's not so small you can't see it, and if it's not so large you lose your square. I mean, we're working in the real space at the moment, so approximately like that. Then, so you have a triangle. Okay, mine is not precise, but for the exercise that's almost good enough. Let me get it a little bit more precise. Notice that one corner necessarily of the triangle is a right triangle because you started with a square and the square corner. Now, the next corner at the acute angle of the triangle, the smaller acute angle, you are going to, I hope, I'll tell you what I'm trying to do, and I'm getting stuck. You want to fold the same triangle on the other side, but we have to get to it, okay? Okay, hold this point fixed. Hold this point fixed, and fold the second square, the second corner, in to create a similar triangle. and then progress around holding this point firm and folding this point to create.
Sorry, can you show it again?
Yeah. So you're holding this point firm and folding this up, and then holding this point fixed, firm, and folding this up, and then holding this point firm and folding this up. And I should say that it should always be that you're folding it up on the side itself. So notice I'm holding this fixed and folding this up along the edge of the square. Now, yeah, at some point you must have done it so that you went off the square edge. Let me do that again. You folded any triangle in, and then you hold this fixed and fold this up. Yeah, I'm not explaining this as well as I should, but the net result, let's look at it. The net result should be the pattern where you have a square within the square on a different angle, which is effectively a visual proof of the Pythagorean theorem. Let me see, did anybody, I must have given the instructions slightly wrong.
Is it a huge problem if we end up having a rectangular?
Yeah, you don't want a rectangle. You want, okay, so this goes here.
Or, okay,
I think this
then.
goes here. I think, no, that's wrong.
So I thought the ends were supposed to meet. So this
This
is
is
what I
it.
did.
Yeah.
And then that. And then that.
I'm not sure why I'm fudging right now. Oh, fudging. Fudging. That's the word we were looking for yesterday. Fudging is sabulamak. Fudging. So we talked about adjusting, making minor adjustments. Fudging is the English word for it. Okay, so we can work on this later when we have more time, but the net result is that we get a square within a square that is at whatever angle the hypotenuse is of the triangle that you first folded. And that becomes a visual proof of the Pythagorean theorem. So that a squared plus b squared equals c squared. And the the geometric representation of that, one geometric representation is you have a square, you have a line, you have another line that creates two squares. A squared plus b squared equals c squared. C squared is the hypotenuse, and it creates an AB and an AB, and that's what we've created here. So that the sum total is these four triangles plus this square equals the whole square. I'm sorry, I'm a little bit tongue-twisted this morning. But this is not only a proof of the Pythagorean theorem, which is why it works for every triangle, no matter what triangle you initially fold, but it is also the basis of the pattern on the steps up to the second-story gallery in the Eşrefolu Mosque. Now, that particular photograph, I couldn't download from my phone this morning. I could only download from my camera. So we have some slides, but we don't have others. But with that, let me conclude the first part of the workshop. And let me say that the workshop itself was 12 such exercises using paper folding to explore geometry. So if we feel that we want to continue that at some later point, we can do that in the next couple of days. Now let me see if I can activate this. Okay, so from our experience yesterday in Eşrefolu, I want to relate the slides of my presentation to this workshop exploring initially points and circles, and then squares and grids, and bring out aspects of the mosque that we looked at together yesterday, and relate my comments to some of what Jay Bonner introduced us to, some of what Jean-Marc Castera introduced us to, and Peter Cromwell, and others. I want to talk about the use of color in antecedent Seljuk architecture in Iran, that is colored glazes on architectural monuments. And I want to look at just a few particular patterns in the Eşrefolu Mosque and relate it to earlier monuments and to later monuments. So we'll be looking at Seljuk and pre-Mongol architecture of Iran, just a little bit, and relate it to later works of the Ottoman Empire, and particular Sinan in Istanbul and Edirne. So first, if you see an equilateral triangle or you see a pentagon in Islamic art, what you don't see are the construction lines that were required to create it. Now, many times a pattern can be stenciled, or a template can be used, or other means of repeating or iterating the pattern. But at some point, a pattern, in order to be precise or fairly precise in an architectural monument, has to have been designed and constructed. So the circle, even if we don't see it, is present in its absence. And the center point of the construction of the circle is present even in its absence. So that's an important point to remember, whether you're looking at a simple pattern or a complicated pattern, and we will be looking both at simple patterns and at more complicated patterns. These are drawings in I don't remember, a textbook or a website that are relating to Euclid's Book of Elements. And I probably don't need to remind you, but Euclid's Elements were the fundamental text in geometry used in the Islamic world from the first time of its translation in the 8th century all the way down to the contemporary time. Islamic mathematicians worked and not only translated, but offered commentaries, advanced mathematical thinking, but Euclid has continued to remain present when studying what's called the Euclidean plane. Now, this is the mafil. Is that right, Sarah? Mafil or maksura? In front of the mihrab in mafil. Mafil. It's a detail, and what I've done is I've pulled out an image from underneath the structure. This is one of the elements of the mosque that was introduced during, one might call it the restoration in the 16th century, 1575, from the time of Sinan, that exists in the mosque, and there are many other elements that I can identify that his team must have worked on. But I wanted to pull out the painting on the side, the painting on wood, and the grid underneath. Now, the square grid underneath, obviously, I pulled out to share with you the very simplest pattern that one may find in Islamic art. And there it was within the mosque. But then I wanted to jump to the relationship between the painting on the mafil in Selimiye, in Edirne, to share with you that stylistic affinity of Eşrefolu Mosque and Edirne, Selimiye, with respect to painting on wood in the second half of the 16th century. And notice the Eşrefolu example is actually lesser quality. And one of the discussions yesterday among us had to do with whether the Ottoman elements really were Ottoman because they were relatively so crude compared to Selimiye. And what you have to remember is that Selimiye was an imperial commission. And Eşrefolu is probably, now one could check this in both the Tezkere of Sinan, but also in the Ottoman archives, was probably an order that was given to the royal team of architects and sent out at some point for them to work on the restoration. They worked on a mihrab in Bursa or a mimbar in Beyazıt II's mosque in Külliye in Edirne. They went all over the empire, working, rebuilding, restoring, making additions, as the mahfil here.
The thing is, in the Selimiye version, there are two styles, Rumi and Hatayi, and the one from Eşrefol is just Hatayi. So the upper one is richer in terms of styles used.
In this particular example,
Yeah.
you're relating
so
both?
The top one has two different styles, Rumi and Hatayi, and the bottom one only has Hatayi. It doesn't have Rumi.
Now, the division between Rumi and Hatayi having to do with the Seljuks of Rum and the Seljuks of farther east are relating to Hatay, actually Cathay, China, Eastern. That's a division that, for me, doesn't necessarily work in all situations, and the relationship, for me, that's apparent here is the saz leaves, the leaves that are curved and have very strong
Because it doesn't
indentation.
have any other option. In order to use it in a border, it has to curve, otherwise it doesn't work. In the upper one, the thing is Rumi and Hatayi can't share the same line, same root. So they have to come from different roots, right? That's the difference. So the upper one is more complicated, but the bottom one is a simpler version of just Hatayi motif.
Well, let's agree that they're similar but different and move on, because I have
okay.
a lot that needs to be covered. But it's the saz leaves, and I'm trying to, is this a pointer?
On the other side.
This is the saz leaf, and this is the saz leaf that I'm particularly looking at as most close in similarity. Then, curiously, on the mimbar, on the wall facing towards the mihrab, there was scratched into it a square grid. Did anybody else notice that? Now, in a situation like that, from an art historical perspective, you have no way of knowing whether this was done last week or yesterday or 700 years ago. But I thought it was interesting to note, A, that it was there, B, that it happened just when somebody was asking me what is the word grid in Turkish, and what is a grid? And I turned to think about it, and this popped out at me. It was just amazing. And of course, it relates to the grid that we just made in our exercise as by way of example. Now, turning to look at the mimbar itself, I also wanted to point out this frieze pattern, which is actually a part of a much larger planar pattern, and we talked about that with Jay yesterday, is on the diagonal, but is also based on a square grid pattern with additional lines added within each square. And if I remember the sequence of my slides correctly, I want you to notice this triangular addition and this triangular addition, which were adjusted in the framing of the steps of the mimbar to create a rectangular panel for the frieze pattern. Just by way of visual acclimation to see what we are looking at. Now, if the next slide is not a comparison, then I'll come back to it, but notice those are right angle triangles. I don't know if they're exactly, they may well be isosceles. That's not, okay. So I took another direction. And let me say, what I've done with my lecture is jumble it up and create a series of rambling comments, but that relate to Eşrefol Ujami. Okay, this pattern that we talked about that has a boss that is coming out, a rosette coming out from an 8-pointed star set within an 8-pointed star with 8 petals set within a square grid that can either be defined by these center points of the octagons or these center points around the 8-pointed star. We talked about it appearing in different places within the Islamic world as a pattern and as the basis for a family of patterns. And almost exactly contemporary to the Ashraf-ul Ujabi is Takhti Suleiman in Persian Azerbaijan, which was the capital of the newly established Ilkhanids after the Mongol conquest. So 1272, even later here, the very same pattern with the boss in an 8-pointed star, in an 8-pointed star with petals, but it's executed not in wood or carved wood, but with individual modular tiles, each of which, even with the interlace, is identical, with this 8-pointed star as a secondary element set in. So the entire plane of the wall from Takhti Suleiman, all of the square, little 8-pointed stars have bosses in this instance. This example, yeah, 1272, give or take. What? Yeah, what's interesting, the tiles were found in Takhti Suleiman in the 1930s, entered the market, and were purchased by Doris Duke, who was a very rich American heiress. And she collected a huge collection of Islamic art that she lived with at home. She had 5 homes. Her Islamic art she kept at her home in Hawaii, in Honolulu. And after she died, she established a museum, Shangri-La, Doris Duke's home in Honolulu. And that's where this wall had been erected in the 1930s. I think she purchased these while she was on her around the world honeymoon. Okay. So you see it covers the wall, and I only took a section of it. It not only covers the wall more than this, but there is another of the same pattern with different color arrangements. But the other point here is that rather than the turquoise and manganese combination that we saw yesterday in Ishrafulu, here we see a turquoise glaze and a cobalt, exactly, giving it the darker blue. And the second important difference is these tiles are molded rather than carved. So it's stamped and molded. So it's a very different technique of manufacture. Okay, maybe here's the sequence, yeah. So this triangle and adjustment, Jean-Marc pointed out to me this triangle in the pattern around the mihrab. It's a poor photograph of it, but there's a 45-degree angle, a hypotenuse with 45, 45 here, and it's replaced on the other side. So just as Jay was saying that there's a pattern on the mihrab and the fundamental structure of it is repeated on the mimbar, we're also seeing tiny little details of design that are repeated and reflected in the mimbar and the mihrab, that there's a relationship here, yeah.
I'd like to just point out something. It's not clear here, but I realized it yesterday. So I think what they did in the mihrab was they used a couple of different kinds of border, but they didn't want to put them just next to each other. So what they did was Rumi motif was following, and that what's that shape? Plato's thing? That,
the Archimedean,
yeah, Archimedean
structure,
thing.
the cuboctahedron.
Right. So the Rumi comes
This.
here, and it changes, it shifts the path. And it's like coming like this in the Archimedean thingy there, and then it gets into one layer inside. And there was another border, so they were kind of twisting. So coming like this, parallelly, and twisting, and coming down. And it was amazing.
Yeah,
So-
it's amazing.
So that's the
And-
trick, I think, that they use, the reason why they use those Archimedean spheres, whatever.
Well, the subject of a whole nother seminar
Yeah,
is the issue of symmetry breaking.
Yeah.
How and when and why
Yeah.
is symmetry broken? But that's another week-long seminar. I'm going to keep this, I hope, shorter than a week. That's okay. Very quickly, I want to also point out from, I think it was the 1160s, it might have been the 1170s, the very, very famous wooden mimbar that was made by a craftsman in Aleppo under the commission of Nur-ad-Din Azanji ruling from Damascus. And this is the mimbar that he commissioned. It was finished by his successor, Saladin. He commissioned it while the Crusaders held Jerusalem to install in the Aqsa Mosque after the Muslims had recaptured Jerusalem. I mean, this is amazing. I mean, imagine this would have been made by the greatest practicing craftsman at the time. And then in the tenure of Saladin, when Jerusalem was captured, this, in fact, was brought to Jerusalem, to the Aqsa Mosque, where it happily resided until 1969, when it was destroyed by a fire set by an Australian in Jerusalem. Not even known if it was part of a political act, but it was destroyed, and then it's since been reconstructed in an international effort of reconstruction. But absolutely extraordinary. Again, a boss, 8 pointed stars, whoops, and octagons. So a relational similarity to Eshrafolu Mosque, but not exactly the same pattern. And also under the patronage of Nur-ad-Din Azanji, there is a minaret constructed in Toli, near Erbil, the base of which has this extraordinary range of geometric patterns, again using only a turquoise glaze. It's a very friable brick. It hasn't survived well. This is reconstructions by Rima Ajluni of some of the patterns around the base by a method that she's developed for the reconstruction of historical patterns. And we'll come back to some of those elements. But those three monuments, the wooden mimbar from Al-Aqsa Mosque and the Choli minaret, and I've already, Takhti Suleiman, all give examples of parallels of works related to what we saw in Eshrafolu Jami yesterday. The last point that I want to make is this detail in the Muqarnas shows two pentagons and what Peter had called, I think it was Peter, a bobbin. It looks like a bobbin shape, so something like this. Around it. What's interesting is this is more like a bobbin and less like an hourglass, but this is an example of the issues that little issues that we deal with in terminology. But two pentagons and this thing shaped like that, which also appears in the mimbar in the doors. So here's the two pentagons, here's half of that hourglass or bobbin-like shape. And I had asked Jay why he thought those elements were extracted and so highlighted in the door. A question raised to which there really is no answer at this point, wouldn't you?
But it ties them together once again.
It ties them together, absolutely. And shows that design relationship between the mihrab and the mimbar in this one monument setup. You'll recognize this. The pattern that you were working on happens to be the pattern that we attempted to create. It's a little bit larger because it has not just this interior square, but the triangle is reflected to create a kite-like form all the way around the square. This is from an early mosque in Antakya in Hatay province of Turkey. And my slide of the pattern in the screen going up the stairs to the second gallery at the front of the mosque yesterday. As I said, I couldn't transfer. But here's a detail showing the extraction of the square of the pattern related to the one that we constructed, attempted to construct using paper folding. Just to give a quick historical overview, I don't want to focus on the details, but the 4 monuments, 1, 2, 3, 4, yeah. 2 from Harakan are the earliest, second half of the 11th century, and 2 tombs from Merakeh, Gumbadi Surk, and Gumbadi Kabud I'm going to be referring to in the next group of slides. And what's important to know is the Harakan pair is earlier. One is a little bit earlier than the other. And the 2 Merakeh monuments are not directly related to one another. They are among 5 or so tombs standing in a particular area. Gumbadi Surk. Okay, I need some help here. Okay. Gumbadi Surk is mid-12th century, and Gumbadi Kabud is late 12th century. And that relative chronology is good enough for our purposes here. When I say that the Harakan tomb towers are a pair, they look kind of like twins. They're not exactly twins because the earlier tower has one pattern within each arch on each side, and the later tower has 1, 2, 3, 4, 5 patterns on the face of each side, and there are several other differences, but the similarities is that they both carry the same Quranic inscriptions, but for one change. We'll come back to that later. What I want to focus on very briefly is one of more than 100, almost 200, geometric patterns on this monument, and see that the pattern constructed of cut brick is intersecting octagons. And this pattern, again, so we're dealing with late second half of the 11th century here, and the same or similar pattern of intersecting octagons, spaced a little bit differently, was on one of the screens at the back of the mosque, with the addition of a paired square grid. So again, relating it to the pattern that we constructed in its most simple form. And looking at the screen then moves my mind to the next association, and that is that some of the screens in the Ashrafolu Jami struck me as more closely related to Ottoman screens and Ottoman work than to Seljuk woodwork. They are plain on both sides, bare of any additional ornamentation, do not have grooves and ridges, are not precisely, or maybe this one, maybe the ones that I looked at were not precisely interlaced, and the interlacing here is not actually an interlacing but abutment of pieces of wood. Now, I didn't capture the intersecting dodecagons as a pattern, but this is a slightly more complex pattern, but you see the simplicity and the formal elegance of the screen carved in marble from Selimiye at Edirne to capture that relationship that I'm trying to establish. And the argument as to whether that set of screens in Ashrafolu is or is not Ottoman or related to the time of the Ottoman Restoration in the time of Sinan is again the subject of another seminar yet to be developed. I think there's another slide coming that relates to that. But I want to switch focus now to the pattern in cut brick on the tympanum of the later tower at Harakan, so 1096. And Jay, I think you had mentioned the earliest pentagonal pattern that you had seen was Masud III's tower. Do you remember the date of that in Ghazni? It's also 11th century, but I don't remember whether it's earlier or later.
It's early 11th century.
Earlier. I think it may well be. And this is not a pattern that, in fact, is generated by a pentagon. The pentagons fit in between areas of the pattern. But my sense is it is part of an experimental process leading to what we see at Eşrefolu, which then again leads further on in the works of Seljuks of Rum in Anatolia, Rum. So this pattern can actually be analyzed in a number of different ways. The axes of symmetry are shown here, a square grid, not a visible grid related to what we are looking at. And each set of elements within each square is reflected across a vertical axis and reflected across a horizontal axis. If we connect the centers of some of the pentagons, we establish a hexagonal grid with a horizontal orientation. And if we connect the centers of other pentagons, we establish a hexagonal grid with a vertical orientation. And as you recognize, these are not regular hexagons, but they are equilateral hexagons, so equal sides. And then if we take the crossing of those two polygonal networks, we can identify a unit that is pentagonal. That is, it has 5 sides, beşgen, again, not a regular pentagon, that forms the unit that is repeated to create a tessellation across the plane. And taking this several steps further, that relationship can be geometrically related to a network of overlapping octagons. So we're playing extensively with the geometry inherent in a circle, divisions of 8, and further divisions and connections and erasures will yield a pattern like this, a tessellation of pentagons. This is one of the few, was it Merak who mentioned, who was mentioning the tessellation? Tessellations of pentagons. No, Hussein was mentioning it, that there were only 14. It's not an infinite number of possibilities, which, well, this is second half of the 11th century. This is the Buzjani text with the anonymous treatise in Paris. The anonymous treatise is arguably datable to the 11th century, which I argue it is, but others have argued that it's 12th, 13th, 14th, 15th, 16th century. So a big question mark. But you can see that the geometric structure of it is very close and related to what we see at Karakan and what we've seen several times in the last few days. Another layout of this pattern I've related to the method that is proposed for its construction using a wooden framework to set in the cut brick elements and then affix it to plaster and affix it to the tympanum of the building. The same method that we may have seen yesterday, that the ceramic pieces are assembled face down on the ground with plaster set between them, and then the panel is put up and inserted into the building and the monument. Shift now to Gumbari Surk. And Jay, this is the building that I wanted to mention to you that has turquoise glaze with cut elements after the glazing process. And it's interesting in particular because what that turquoise glaze is used for is only the outlining of intersecting nonagons. Nonagons are not constructible, or at least at this time were not constructible using compass and straight edge. I can only imagine that they were highlighting the nonagons with the new technology. This is the earliest such use of turquoise glaze in a decorative manner, middle of the 12th century. Hussein, how am I doing for time? I wanted an hour and I started late. So aim for 10, 10, 10. When? Okay, so I should be. Okay, so I need to finish up. I'm going to go maybe a little bit faster. I've highlighted the centers of the the overlapping hexagons, and I didn't have a chance to grab Jay's slide of the dodecagons overlapping that were based on a hexagonal grid that we saw yesterday at Eşrefolu. But we have the same thing working here, where the center of each hexagon is also, or some of them, the center of each decagon, and a dodecagon. So there we see the intersection of the dodecagons, and I've extended them out beyond the arbitrary border of the tympanum so that you begin to see the pattern. And at the same time, we have intersecting nonagons, which are also using the same center points as the hexagons. And it's this feature that is highlighted in the Turkish glaze in cut sections from tiles. The use of a single turquoise glaze in cut elements of glazed brick is also in Nakhchivan, late 11th century, just before Gumbadi Kabud. As I said, this is the beginning of a tradition which develops substantially, and by the late 13th century, more glazes are used, more glazes are added. Contrary to Jay's assertion that this comes to Turkey and goes back to Iran, there may be a back and forth, but I think one can trace the development within Iran itself. This is a detail again from Takhti Suleiman. This now is later, well post-Mongol into the 14th century, and you see again the continuation of two different color glazes, but with the continued use of cut brick. In Seljuks of Rum, brick was not used, stone was used. We touched on that a bit yesterday, but for the dome, and we'll come to that towards the end of the lecture. I want to highlight this pattern in the spandrels above the arch in Gumbadi. Oh, one more relationship. I figured out a way that this could be constructed with modularity to cover the entire pattern. And what's interesting is the dodecagons, which appear in higher relief, is fired clay used to cover the lines of connection of the modularity beneath. Now we focus on this pattern and relate it to the pattern of the spandrels of the mihrab in the Eşrefolu Mosque. And I just wanted to show, when I talk about the earliest start of the tradition, this is on the Gumbadi Surk, and the only other example earlier we have is from Kharakhan, the earlier tower, and it is two little bosses on either side of the main entrance. So virtually no presence of glazed ceramic in architectural decoration before this time, and the tradition grows and grows and grows. The most famous monument, I'm just going to go through these slides quickly, not focus on the main pattern in Maraghe that has received so much attention. That was after Hulagu established his capital there, the center of the scientific school, an observatory of Nasir ad-Din Atusi and his scientific colleagues. So Maraghe has a longer history for a couple of hundred years in the scientific community. Again, relating this pattern to contemporary, what I think is contemporary textual evidence and the overlapping of decagons. We're going to focus for a moment on this tympanum, early use of muqarnas, and this spandrel in which there's a sequence of 5, 6, 7 pointed stars. I can't remember why I put this in here. Oh yeah, I remember. You see this cornice of muqarnas, and that's related to the muqarnas that we see here used in a different manner. But here we go with the stars. It's an interlacing two polygonal networks, one curvilinear, one straight, The lower one is straight with 5-pointed stars, 6-pointed stars, 7-pointed stars, 6-pointed stars. So 5, 6, 7. And here I've highlighted the two different networks, interlacing and highlighted in a cartoon-like manner the stars. I just want to touch on the Quran part of my talk, and that is to refer to Abdus Salam, who received the Nobel Prize in, I think it was 1979, who in his acceptance speech quoted this verse from the Quran as a physicist and called this the verse from Surat al-Mulk, the physicist's verse, because it relates to any imperfection, that is, from mathematics to physics, one moves from the idealized world to the physical world. Seest thou any fissure? Return thy gaze again and again. Thy gaze comes back to one dazzled and weary, which is what physicists experience on a daily basis, and all of us exploring Islamic pattern experience with regularity. This is the verse that is selected for use at Maraghe on the Gomadi Kabud, in the monument that has one of the most complicated patterns. And I'll end with a view up into the dome above the mihrab in Eshref ul-Jami, and relate it with its pentagonal, pentagram and pentagonal form in the center of the dome, constructed of brick with glaze, to the great dome in the North Dome in the Masjid-i-Juma, Isfahan, late 11th century, with no glaze, but constructed of brick and cut brick, and with, again, a pentagram, that is a 5-pointed star, in it with what's been called double ribs. And what has fascinated me in my work, but not with any yet solution, is that those double ribs can also be perceived of as the 5 rhombuses that fit within a pattern created by overlapping dodecagons that is related to the most early famous complex patterns that have both pentagonal and decagonal symmetries. So let me end there. And there may or may not be time for questions. Hussein, is there a moment for questions? Or yeah. Questions? Anybody? I know I've thrown a lot at you, and we've all had so much thrown at us that our heads are probably pulsating at this point. Jay? If they want to capture it, you should.
Thank you. That was really great. And I just wanted to add a comment about the North Dome chamber in Isfahan that you have the photograph of. That it's very interesting to me also because that 5-fold structure on an octagonal dome is so unusual. Because
how did they make the transition?
Yeah, well, I've determined that the 5-fold pattern in the dome is based upon a dodecahedron.
A dodecahedron rather than a decagon. That makes sense.
So it's actually a dodecahedral structure atop the octagonal chamber.
That's brilliant.
And it's interesting because there are a number of examples, not too many, but a number of examples in Islamic architecture of domes that are derived from Archimedean or Platonic polyhedra. But this is certainly the earliest, and it's also one of the earliest patterns that uses a network of pentagons, in this case on a spherical surface rather than a flat surface, to create a pattern.
I don't know if everybody catches that, but we're right back to the inherent geometry in a circle. And what's interesting is you think of 5 figures with pentagonal and figures with dodecagonal, 12-sided and 5-sided, as not being connected with one another. But the dodecahedron in 3 dimensions has all pentagonal faces, right? So you've got 12 faces each of which is a pentagon. And what Jay is saying, I've been thinking two-dimensionally in terms of relating this pattern to overlapping decagons, 10-sided figures. And he's saying, no, think of it conceptually in 3 dimensions related to a dodecahedron, a 12-sided 3-dimensional figure, Platonic, not Archimedean, that has pentagonal faces. That's absolutely brilliant. Okay, well, I hope we'll find time to do more of the exercises with paper folding that bring you into that relationship. What?
I'm curious about the second plate.
Yeah. Oh, the second plate. Yeah. What I was going to do is we were going to make a we were going to make an icosahedron, a 20-sided 3-dimensional figure with a paper plate. But we can do that over lunch or something. Okay. Well, thank you very much.